Okay, everybody, welcome back from lunch. We are going to go over the next assignment and then the next PowerPoint that goes along with the assignment. And the assignment's actually in two parts here. Here's the assignment here. It is assignment number 4, but it says 3 inside of it. So I didn't change these around properly, I guess. However, I'm sure you can probably figure out the name of the assignment. Number 4 is really the assignment, not really what's inside of it. So don't worry about that. If I think about it later on when I have you guys working on stuff in a few minutes, or not a few minutes, but in about an hour from now, I'll have you guys doing some stuff. And then while you're doing that stuff, I will, maybe I'll go ahead and edit that stuff. But don't worry about it if you can figure out the order. This one is going to be on setting file permissions. I'm going to let you do this one on your own. Because this one you probably want to experiment with, but I'm going to go over file permissions. I'm also going to go over this concept of linking, and so this part up here, the first part of it, which says file access permissions, is what you'll be doing for this assignment, and I'll go over the PowerPoint part of it in a few minutes. Show you everything about how to set these things, and then you'll be running a change. We've already changed the permissions on a few things, but you'll be doing some more stuff, and I'll show you that. And then turning on rewrite, turning off rewrite, try editing a file, what happens. This is just simply answering questions, copying a file, when you copy and retain a file permissions. And then we have this section here called links. So we have links up here. Links are referred to as creating a link. We have symbolic and we have hard links. Hard link is when you create a link in the directory structure, it's like creating a directory but not creating a directory. You create basically a copy of a current directory and you're creating a new way of getting at it, a new path. It's an ln command. And I just tried it a few minutes ago because I didn't think it was going to be supported on these drives. And it's not. But we can do symbolic instead. So ln is the link command. So if I were to make a hard link to your test file in the same directory as test link, when you make a link, it's like you do this. For example, if I do a directory link here, I can just take, as an example, ln, and this assignment wants you to do a file, but let me just show you something real quick. You're going to get an error. If I go ln for link, I'm making test as an example, and I'm going to copy it to my test. What am I going to do? I'm going to make another link in the inode list. I haven't gone over links yet. But I'm trying to do it now with an example, where you're going to put another entry in where you're going to make a hard link so it's the same. It's like almost having two same files, two same directories, but they have different names. And they're both going to share the same information. So as an example, if I do this, I'm going to get a hard link not allowed for directory. Because I can't make the hard link on the server. It's not going to work for us. It's not going to be allowed. So instead, I want you to do symbolic links. So you put a minus s in front of it. And I can go minus s for symbolic. Makes it symbolic. It doesn't really make it. A hard link actually makes the entry. It copies a directory to another directory with a different name with the same contents. So it's not two separate directories. Those are two links to the same directory under two different names. Huh?
Like a shortcut.
Like a shortcut. Very symbolic link is like a shortcut though.
Oh.
Because it's copy of. Hard is like it's in the inode system. It's not symbolic like a shortcut. It's a real link. You can't do that. We can't do that here. But most people will think of a link as either symbolic or hard. Hard is a real link in the structure. We can't add to the structure, however. It's not going to help us.
Oh,
we can actually, you know what, I'm going to test with a file here. But after I'm going to do the symbolic. So I put the minus s in here on the bottom. If you see this on the bottom of the screen here. Minus s does work. So now I have a new entry, and it shows up. I just did this a few other minutes ago with a gamma directory. And now if I do an ls minus l, I see I have my test that's symbolically linked to test. And over here I have an L instead of a directory. It's not a directory, it's a link. It's a symbolic link. So it's if I change the directory here to test, and I list out the contents, I see BHH in test. If I change the directory to my test, and I list out, I see BHH. I see the same file. So it's two ways of getting at the same location in the file system through a symbolic link. So I can delete the symbolic link, and test is still there. So what if this is, people do this because they have this really, really long directory structure. And it's got 5.9.9.3.4 and all in the name, right? And they don't want to keep typing it all over. So you make a symbolic link, it's like an easier way of getting at the same information. But it just says my directory or something, or it says Linux. Because you're going to build a kernel as an example, and you're going to put a bunch of stuff in there. And you're going to have this. The path is going to be huge. Take that whole path, make a symbolic link out of it, and just say my build or bin. And then you make it smaller. So I can get everything through test. I can get at that through my test. So that's the symbolic part of it. The link makes the link.
By default, it will be given all the three permissions?
By default, it's actually given the same permissions as it's supposed to be given the same permissions, but I see here now it's got all the permissions. So this has got read, write, execute. Part of the assignment is to try a few things and see what permissions are. Same directory. This is a hard link to your test file in the same directory as a test link. Does it have the same? Does the link have the same permission as the original file? This is for a file. I just did it for a directory. I can answer that question and say no, it doesn't. So if you change the link access permission, does the original access permission change? Try it. So I want you to experiment a little bit with it. All you have to do is create. This one's for a file. Let's see what we have in here. That was a directory, so if I do link, actually let me just test this real quick actually. The hard link did work on a file. So it's not, the hard link is not going to work on a directory. Symbolic link will work on a directory. Hard link just worked on the file I just ran it. ln is the hard link command. Minus s makes a symbolic out of it instead of a hard link. ln stands for link. I just took this file, so I don't want to do the assignment for you completely, but I'm just doing the assignment for you in essence. But making it, if I go ls minus l and I take a look at it, I see that, wow, that was identical. The symbolic link, however, didn't make identical properties, but this one did make it identical. So I see it's actually the same. But if I take and go nano test BHH, and I have in here, I had 1, 2, 3, 4, 5, 6. So let's put 8, 9, 10, 11, 12, 13. And then some dots in there. I'm changing it, right? And this I'm changing the file called test.bhh. And I save it, output, and I go like that. And I exit out, and I cat test BHH. And I see it's changed, and then I go cat BHH. And I go, oh, what happened? That changed too. So it's two files that are linked together under two different names, and they both have the same contents. But one's a hard link. I didn't copy it. I didn't move it. I used ln. I linked it with a hard link. You can hard link files. You can't hard link directories. Because if you hard link directories, it messes up the structure. Plus, also, in some systems, you can make it so it does work. Normally, you can't hard link a directory, but you can hard link a file. Why do you want to hard link a file? Well, you want to have one file that everybody's using, that everybody's editing, but it has one name, but everybody has a different version of the file with their own different name. Then you make it all consistent. So you don't have to give out the name of the file that the user is using. It's all, they're accessing it through the same name. So it makes consistency, maybe, perhaps, among many different files. It's just a concept that we use in Linux or Unix that we don't use in Windows. So it's not really a shortcut. It's because you're accessing the same file simultaneously along with the other access methods. So thousands of people can have the same hard link to a file, and it's the same file. So you're sharing it among multiple people. Everybody's editing the same thing, but you might have your own version of it with a different name. So, which is actually kind of interesting. Or you might not have it. You might be using somebody else's file under your name. So there's some interesting creative use of that. And the symbolic directory is usually just created for convenience. You don't have to type a huge old path. You could just type a small path. So, and you notice in here we said the symbolic, the L for linked directory, and we see this arrow goes on here. Here we don't see anything. If I list it out, I see I have 2 files, and I have BHH and I have test BHH. So if I remove test BHH, oops. Oh, how about if I type in remove test BHH, then I list it out and I see I still have BHH.
Can you soft link a file? Or symbolic link a file?
We'll try it. We'll symbolically link a file. So if we go back this way, I removed test so I can still have it. And I see, and I go back this, and I go, see how it's in like a color?
Yeah.
I don't know what color, turquoise kind of color. Let's just see what it looks like. All of a sudden, now we have this link in here. It's a link. So we can get the same file now through this one. Well, it's the same. It's a hard link or a symbolic link. The hard link actually exists. This symbolic is a pointer. So if you don't know pointers, you're kind of lost. But if you think about the file system in Unix, it's inode based, which is pointer based. So you have this list of pointers to hard disk space. And you're creating, imagine pointers in C. You remember if anyone was taking C. And you create all of these pointer variables that point to memory. You can have thousands of pointer memory variables, all pointing to the same piece of memory. So that's what this is doing. The symbolic link, you get one piece of memory, and you got 2 links to it. Whether it's a symbolic or a hard link, it's the same concept. Whether or not it's a directory or a file, you can do a hard with a file. You can't normally do it with a directory because then it messes up the inode tables in terms of the traversal through the system. What you're really doing is creating a pointer, and the pointer is just going to it. So are both going to change? Is only one going to change? Are you going to make a copy of it versus are you going to make a hard link is going to be a copy of that data you're going to actually put into another file, so you have two capabilities. So it's kind of interesting. So like for example, let me go back and test. Let me go back here. If I have test BHH and it's going to BHH, and I go down here and I say, well, nano, let's just go nano. Here, I'm going to make another one here. Link hard BHH, and it's going to go to BHH. Oops, where am I? Link. Oops, I'm sorry, backwards. BHH to hard BHH. And I list things out. I now have, this is the original file, and I have a hard link created called hard BHH, and then I have a symbolic link. It's just nothing more than the pointer to it, and I have a little pointer symbol actually. It looks like a pointer actually. So let's see. Let's nano hard BHH, and I'm gonna put underneath it Larry. Put Larry's name under there. And then exit, and then I go cat test BHH. I see Larry, and I go cat BHH. I see Larry, and then I go cat. Whoops. Test B. Did I do test BHH? I think I did them all. Oh, hard BHH. I'm gonna get Larry down there. So I got Larry for all of them. So let's nano BHH and put Mo underneath. Effectively, we can actually just do this again. Cat BHH, we got Mo. Oops, there's Mo. So you're wondering, what in the world do we do? They're all the same. They're all the same. Yeah, they are the same. Hard, symbolic, they're all the same. It's all pointing at the same piece of memory. They're all going to change for everybody. But one actually makes an entry, the other one just makes a pointer to the entry. So do we want a new inode, or do we want just a pointer? The one's a soft, they call it a soft or symbolic, and the other one's a hard. Are you going to make an entry, or are you not going to make an entry? It's just a matter of storage in the inode tables. So they're all doing the same thing, though. They're all going to basically do the same thing. So a lot of people will take the symbolic because it takes up less memory. I'm going to add to the inode table because symbolic's throwaway. Just take it away. When you add to an inode table, you add to the list of what's being traversed. So if you imagine a directory structure, we're going to create this huge tree of stuff. We're going to put all the stuff in here, and we're going to search this tree. And every time you search it, the more entries you have, the larger the search space, the slower the search works. You put a symbolic one in there, you don't add a new entry in the tree. You just have a fake pointer that you put in there. You just use the pointer. It's not part of the tree anymore. Not part of the tree, it doesn't take up as much space. Makes the search space, doesn't make or increase the search space. And then you get rid of it. You throw it away when you're done with it. Problem is people forget to throw it away, or they get rid of the original. So let's just get rid of BHH. So let's see what happens when we try to remove it. If we try to remove BHH, and then we look at this and we go, oh, what happened? Now we have hard BHH still exists because the entry is still there. Then we have this problem now with test BHH. It's now black. It's a problem. It's pointing to something that's not there anymore because test BHH was pointing to BHH. It's a symbolic soft link. Hard BHH, we actually made an entry for it. So if I cat out cat hard BHH, the sucker's still there. We just made a copy of it. And if I cat out now test BHH, I get this thing. It says no such file or directory, but it's still there. So when you see black around the back of it like that, it's a problem with that. You probably should delete it. Because then that sits around and people go, oh, let's use it. It's because you made a symbolic link and then you deleted what you were linking to. In C, they call it a dangling pointer. That's a dangling link. That's a dangling symbolic link. So you should probably just remove it is what you should do with it. And then it goes away, and then you go, okay, we're back to normal. Now we have our hard BHH, which is the same thing as our original BHH. We can hard link it back. So it's kind of like a copy, but you're not copying it, you're making a link out of it. So that is this part of the assignment here. That's the new stuff. I didn't really have lecture material in it, so I just show you that. So keep that in mind for your links. Directory access, we actually did most of this already. But now we're going to be copying, so I'm making a directory called dat, and then viewing the contents of the permission of the directory. Working with directories and working with files are identical. So you know how to do this, but we haven't done any very much copying full directories and moving full directories. So keep in mind, this is not scary. This is what you've been doing. We're just applying it to directories. So you already know how to do it if you know how to work with files. So let's talk about files, and let's talk about file permissions. So the next part of this lecture is lecture number 3. Now I'm not going to go through all of this because we've covered some of this. There's a little bit of an overlap. So if you're looking for more information on Unix, understanding the role of the operating system stuff, we already covered all this stuff. I'm going to skip to the middle of it. Traffic cop communication system, toolbox, shells, command switches. Don't have to review any of this stuff. We already did all this stuff live. Directory structure, but here's actually kind of an interesting thing we didn't cover really on the backslash. I call it's a forward slash. I have the really bad habit of calling it a backslash, but it's a forward slash. We don't use backslashes. DOS uses, or Windows uses, backslashes. And Unix uses forward slashes. It's just a direction. You know actually how you remember it is because it's leaning forward or leaning backwards. That's leaning forwards. Anyway, typically only system administrators have full access to root directories. Just keep that in mind. You're pretending that you're at a root when you're at your home directory. And then we have the absolute path. Absolute path begins with the root. The relative path indicates the location relative to the present working directory. That's where the dot dots come from. You use the dot dots on the relative. It just says wherever I am back there, go forward. or take me back, or take me forward. So the command pwd, we know that as well from earlier, so it's a little bit more review on that concept for working with directories. Pwd will give us our path. So the / represents a directory. / dot represents current directory. So you can copy. This will help you with the copying into directories, actually. The dot represents parent directory, so / dot. And then the tilde, we haven't seen this very much. I'm not sure if it's going to work on your home, but you guys are inside a home. It'll work for me. I'm not sure if it'll work for you, but that tilde should represent your home directory for who you are. So it represents the user's home directories, the / tilde. I don't use the tilde very much, but you might find it handy. So don't use spaces in directory names. We figured that out on the first day of class. Use the underscore character or camel casing. So camel casing, we capitalize the second letter. They are case sensitive, usually in lowercase and with camel casing. Most people will put the directory name in lowercase. So it's more of a best practice. I'm using make directory to make a directory, and we've seen that before already. And that ls minus l gives you more of the full details. So you'll need to use the L, the minus L with the assignment in order to see the directory permissions. So if you just keep that in mind. So here's the part that I wanted to introduce to you that you're going to need for the assignment. We've actually seen this already, but we haven't seen the numbering yet. So permission sequences are found at the beginning of the directory listing. We've seen that before. There's 10 of those characters in there. So we got one of them here on the side, which on the end is the D. My mouse doesn't work in here, but we got the D that's on the side. He's the oddball. And then we got 9. So we got 9 plus 1. And we got 3, 6, 9. 3 for 3 categories. So 3 for the owner, 3 for the group, and 3 for the world. Now, most people call it other. I call it other. It's really the world privilege. It's everybody or other. So the owner is the person who usually created the file. So if you create the file, by default, you'll get read, write, execute. Now, if you want to give it to the group, we haven't done user accounts yet. We'll do that in the second weekend. Then you can provide it with group, but normally they can't write it, but they can read it and execute it. How are you going to execute something if you can't read it? That's a problem. So we figured that out actually when we started playing around with permissions. Yesterday when you put an X on there, actually a couple of students came up to me and said, well, it doesn't run. Not going to run. Even though it's an X, it's not going to run. You have to be able to read it. So reading the file, in fact, if I go a little bit further, I can skip here. I'm going to go to then I'll come back to the permissions. What is reading? It's the first position in the triplet. So we got 3, 3, and 3. Always the first position. So it stands for read. Grants permission to view the contents of the file or directory. So it's a view / read. So you can read it. Does it necessarily mean you can run it? No. So that's kind of a misleading. It's not. It's just access to it, really, to view or to access. The write is to change. So you can read it. So the second position, the W, stands for writing, grants permission to modify the file or contents of the directory. So all of these apply towards files and directories. So then yesterday someone said, hey, look, I can bring it up in Nano. And I said, well, try to save it. So you can read a file, you can bring it up in Nano. Nano will let you change it, let you do everything to it. But what happens when you try to save it? If you don't have write permissions, it won't let you save it. Which is kind of misleading because you think you're in a word processor. And if you're on a Windows system and you load up a document and you can see it in the window and you can change it, you have the illusion, and normally you can save it. No problem. A little different. You can read it, you can change it all you want, but you can't write it, which is what that W is. So, and the minus sign is the negative. They should just leave it blank, but you have to have a space holder, otherwise you can't see that there's 10 characters there. And then the X for execute, which is actually kind of interesting. It stands for execute, grants permission to run an application or open a directory. So you don't go, let's go back to here again. You don't give the directory, you give it a directory, but you don't put X on it, and it's a directory, you can't change directories. You can read it, you can write it, but you can't change to it because there's no X, which is kind of ironic when you think about it. So you need the X in order to access the directory. So this is where most web developers run into problems when they start setting the parameters and they go, well, there's no execute. We're not going to put any execute on the directory. Well, great. You just turned off your website because no one, they can read it, they can write it, but they can't change to that directory. Oh, man. And then you just disabled your entire website. And they go, how come I can't get to my website? And then they go 777. Oh, we did everything to everything. I'll show you 777 in a few minutes. So first character represents whether the listing is a directory. If it is a directory, the D shows up. If it doesn't, we see the line. Otherwise, we see the line. So I just went through this. The remaining 9 characters are divided into 3. First tuple represents owner, second is the group, third is the other, or the world. We went through read, we just went through write, we just went through execute. So how do we set it? We've got numbers. I like the numbers. Yesterday we saw, or today actually, we saw UGO or UGW for world. Depends on the system you're on. I'm familiar with other or O. And we go plus W, plus R, plus X, or plus WRX. Give them all of it. That's the user-friendly one to say user, because you don't have to say user and group. You could just say user. So chmod U space plus W or plus R. Better way of doing it, I like the numbers. So how do the numbers work? In changing permissions, you can decide what number will represent the permission for the tuplet. So you have 3 numbers you set instead of all that other stuff. It's shorter. So you can do this by determining whether or not the permission is turned on or off. If it's on, the value is 1. If it's off, the value is 0. After deciding which or whether the 3 permissions in the tuplet are going to be on or off, you have a binary number that comes out of it. So you can convert the binary to an octal equivalent, and here you go. If the permission is off, 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 you get 0, 0, 0, or the octal 0. So the 0, when I went chmod 0, 0, 0, you just turned everything off for user, for group, and for other, or world. So I want just the one position over here. That's a 1. That's pretty low to execute. And most people think that execute would be like a highest position of anything. It is in Windows. If you can't execute something, then you can't do anything with it. Well, the funny thing is it's like the least amount of worry. Let's just give them execute. It's like a low number, 1. So then we have the second position, the right, but everything else off, that's a 2. And then we have, we just increase it. And then we have the WX, well, that's a 3 from the 0, 1, 1. We're converting binary to octal is what we're doing. Continue a little bit further, we go as high as 7. Because we can go as high as a binary 1, 1, 1. So if you want to give everyone everything, it's 777. Most people would go 650 or 666 or 660 or 670. 650 is probably more popular of the 6 group. And you're wondering, what's that? 6 takes the execute off. And the execute is usually what people don't want people to do. Well, what are you going to execute? Directory. So you can't go to that directory, but you can see the files that are in the directory. As long as the application that's showing you the files is allowing you to look at the files. Which means you're never gonna be able to touch anything in the directory because you've got it turned off if you set a directory this way. But you can look at the file. So you can look at index.html, but you can't edit index.html because you can't go to the directory to touch it. But you can read it, no problem. And you can write it theoretically. You can write all you want. You're never going to be able to save it. So, which is how you can play around with websites. So this is where you get the numbers. You set 1 octal for each position. There's 3 numbers. So if you remember 777 and 000, you got both extremes going on. So when you write your assignment, you can use octal numbers, or you can use the user, group, and other with the R, the W, and the X if you want. It's your choice. So here's your change mod. once you establish the octal number on each octal, you use it to change the mode, or change mod, which is what change mode stands for, to give the directory permissions. So here's our syntax. It is change mode 755 public underscore HTML for the directory. So typically directories and executable files are 755. 777 is unnecessary, really. 755 is enough. Well, you give 644 permissions to other things. For files is 644. Because they can execute it, they can't write it, take the right away, but they want to read it. You want to give them read execute. You want to make sure if they're actually going to change to the directory, you give them directory access to change, which is execute. So I know it doesn't seem like very much, but it's a good reference for you to look at if you want to know the number convenience. It's in the slide set. So anyway, going back to a few more tidbits here about navigating. We know how to change the path by cd path with a /. We don't actually have to put the / before it. So it depends on what kind of syntax you're used to from a Windows version. But we're doing a parent-child relationship in the navigation, which is why the path doesn't matter. Excuse me, why the / doesn't matter on the parent. Because we know the parent, so we're not traversing through it. So if we go cd ... we go from child to parent. And then if we go ... /... then we're going from grandchild to child. So, to move from grandchild to parent. Or the dots. The two sets are bringing us all the way back up. The first set brings up the child. The second set brings us back up to the parent. And then we can go ... /child 2 to move from one child to a sibling directory. So you're not moving the level, you're just going from one child to the other child, different directory at the same level, or underneath the parent. So you're not going back up to the parent, you're just going sideways, horizontal move. So. The list command, we have the ls. We've seen this before, adding the switches. To move one switch to concatenate another, you just add it. So I've been running it with 1 so far. -L, you just put the next to it, so you can go -L, T, W, Z, Y, X, Z. You just add them to the list and run them over and over again. The L showing the long format, that's the one I use the most often. But the A is not bad, it shows you the hidden files. That means you can see the hidden files of the dot and the ... in there too, which is what you're using when you're changing those directories. You also see dot files, as we saw yesterday with .bash and .profile for the shell. .c for column format, show it to you nice little neatly columns, and the T to the last modified date. T stands for time, so it'll show you in descending order on the time. We haven't seen the wildcards, but the wildcards do come in handy, where we have LSA with an asterisk next to it, where we're going to show all the files with A in it. So list A. It's kind of like in Windows you do the ***, and here you just put the star. There's no ***, because we have no dots. So *** is the 7.3 old format from Windows. Don't need that anymore. We just have star because we don't have file extensions. Doesn't mean you can't put file extensions on files. You can. It just doesn't make any sense. When people do that, you know they're from Windows, actually. ls*, A*, A is in there. So any file name with A in it, something before it, something after it. A, *HTML, anything that has HTML, that ends in HTML, whether there's a dot in there or not, then starts out and has A in it. And then all these question marks. Any file with 5 characters in the name, you can't do this. You can't do the last one on Windows, can you? I don't think you can.
No, you can't.
Yeah. But you just put question marks in there, and you got 5. So you can get all the 3, you just put 3 question marks, and you get everything with 3 characters in the name. Everything with 4 characters in the name. If you're looking for something, it's nice to go, hey, that was a pretty long file. What was that thing called? And put like 12 question marks in there, you can get them all. So here's some more. ls, and then we got these brackets, and we're going to need these brackets coming up when we start using the tr command, which is in the next assignment. We put the bracket, and we go ABC, close the bracket, put an asterisk in there. All file names starting with A, B, or C. Oh, that comes in handy. Or A to C, A minus C, same as above, but done as a range, A to C. So you don't have to list A, comma, or actually it's not an A, comma, there's no comma in there. A, B, C, D. If you put a comma in there, look for a file that starts with a comma. This is actually an illegal file name. All files start with characters. Actually follows C convention. So, why? Because it was written in C. So ls, and then we have this caret symbol, A to C, and then an asterisk at the end. All files not starting with A, B, and C. So the caret symbol is the not in the sequence. So we saw the CP command earlier today. We ran a couple of exercises on this. And we used to copy, leaving the original untouched. So we have CP old file, and then we have the path, and then we have the new file. If we're going to put a new file, we're going to leave out the new file. We know that it just copies it with this original file name. So I make a copy of the file with the original. Both have the same name. You go, the original and copy are in the same directory. And then we go index to home as an example. We've seen this earlier. And then to make a copy, we actually have done this. This is a review of what we did earlier. So to make a copy of the file where we have the original's name, but it's housed in a different directory, we just put the directory in there and we don't have to repeat the name. And to make a copy where the result is in a new directory and has a new name, we change the name. So that's kind of the textbook part for this. And we saw the move. So we did the Unix move earlier. We did MV command. We practiced that along with the same syntax as before. It actually follows the same syntax as the CP. It's just a move where we don't get the original anymore. So this one where the file name, rename a file and it stays in the same directory, but it gets moved to a different file. And then we have the one where it goes to another directory with a different name. We saw the deleting of files. You can't delete a directory that has files in it, but you can delete files. So normally you have to change directories or delete and specify the directory that you're deleting from in order to remove those files. That's less than an hour. Anyway, so to delete a single file, we go rm index.html, and then we have to answer yes or no to confirm. You can actually turn the confirmation off in your profile, in your settings, as long as you have to turn off delete. Delete multiple files, you can go rm with the asterisk, asterisk.html. If you go rm asterisk, you've deleted everything. Not so good, actually. So you want to use the asterisk with caution with the rm, because you're removing everything. So you remove rmdir to delete directories. Directories must be empty. If they're not, you get an error message. And then you answer yes or no to confirm to delete it. We know about the password. Hopefully you all changed your passwords. And allows updates for the passwords. And then exit. You're actually supposed to be typing in exit. Mine has been giving me a broken pipe because it's been deleting me probably with inactivity. It breaks my pipe and logs me off, which is actually not a bad feature. In the old systems, if you didn't press exit, you left the system open. You left the connection open. And what ends up happening is you do that a couple of times, well, there's a thread created for each one of those connections. You do it over and over and over again. A couple months down the road, that server is going to be bogged down. You know, because it has all this traffic it thinks it's maintaining connections for. All these users that are connected. They have since gone away. So most servers actually have a timeout now. I've been using Clear. You can also use CLS. My CLS doesn't work though. I'm using Clear, however. And who, we know who, because it tells us who's on the server. We didn't do finger. Finger retrieves information about a user. So if I go finger space, actually let's see if finger is supported actually now that I'm thinking about it. Let's see. I'm going to go finger root. Oops, I'm back at bhecker. Pipe broke. My pipe broke again. Somewhere now I have to go get that password back out of somewhere too. Because I didn't change my password. Oops. You know what it is? If I lost the internet connection or if there's any break in the internet connection, the pipe will break. Let me go pull that password back out now. And now I have to change the password now because people who are watching this video are going to know the name and the password of the user account. So, access denied. Maybe I changed the password already. Let's see. Okay, hold on one second. We'll definitely change this password again. There's an extra space at the beginning here. Hold on. There we go. No, it's good. Huh?
Finger is not installed.
Finger, yeah. All this to know that finger is not installed. Let's see, finger. Yes, finger is currently not installed. Let's see if I can install it. I have not had any luck installing either, so. You know, actually, it'll let me install it. It just won't map to it. It won't give me access because I have the ability to install. Oh, finger is working. No, I did ls. I meant finger. Oh yeah, finger. Finger student. Who's 004? Let's see. They've been up 1 minute and 58 seconds, and they've been idle. No mail, and no plan. No data plan. So I've got 1, 2, 3, 4. That's you. Okay, who is? Oh, I have student 20, 18, 13, 16. Not too many people are installed right now. That's okay. You're probably just listening to me. You're not really doing anything. If you're idle, you probably got a broken pipe. So I wonder if finger works for it. Try finger. Is it working for you now? Because I installed it.
Yep.
It's actually working. Wow, that's pretty good. Doesn't really tell me very much. Let's finger root. Nothing for root. There's really not 2 minutes idle. Messages off. I'm gonna change my password actually again. No, I'm not gonna use that password. I'm gonna use a different one now. Let's think of a different password. Okay, got one. Ah, good. Okay, good. Because eventually my passwords get out too. Because I know I've typed that accidentally. So let's see. Go back. Finger is working. Calc, we did that. Somebody actually earlier today was having a problem with Calc. They were having some special characters on the bottom. I can't remember. I think that's your terminal window that's doing that. It might be the settings in your terminal window. It might also be the buffer. Because what ends up happening is the information comes from the server. It gets sent to your terminal window and it gets buffered. Depending upon how the buffer, it might be getting corrupted or something. So, or it might not be supporting so many characters or something like that. So. Okay, so we have calc, we have date, we've seen date a couple of times. What about this bang bang? So we have bang bang, 2 exclamation points. Pronounce bang bang. Repeats the last command. And then we have a single bang with A through Z repeats the last command beginning with the selected letter A through Z. So let's take a look and see if bang bang works. So what was the last command I did on here? It was calculator. So if I go bang bang, whoops, that's bang bang bang. I got calculator that got repeated. So let's go with bang bang L. What was the last ls command I did? Oh, it was ls probably. I did L. Oh no, I did lane. I did link. What else did I do? I have an M. Let's see. Bang M. I don't think I did a bang M. No, I did a bang. No, M. No, didn't do anything. I don't have anything. But I didn't do it in this session. I got disconnected. So it's per session for the temporary history. I just typed in the word history actually. So if you type in history, you see line numbers. You can actually bang to different lines too. So and here I have a bunch of stuff. I did apt-get, so I did a cp command. And you're looking at this going, where did this stuff come from? This is from like today and yesterday and the day before. In fact, I can go all the way back up to the beginning of time. And then it looks like I did a sudo apt-get upgrade. It looks like I did try to install some stuff. And oh wow, I ran to dpk. Okay. Right in the beginning of time. And then that was like a couple days ago. And then we had yesterday, we have today. The history, you can actually adjust how big you make your history file. If you want to see the history, you type in history. And you can see what you typed in. You can get a limited history with the arrow keys, but you can't get everything. So There's ways of going through that. There's ways of using the bang command to go back and forth as well. So just know that you have ability. The history refreshes itself, actually. And you can set how long and how many days to store your history for. You can also log the history to files so that you can store history for whatever users have done. So I can go in and see, well, what did this user do? What did that user do? By looking at the history file for the user account. So we saw more. We have the pipe more. That's the line going up and down. More. Added to commands. So it displays a list to force the page to stop. So minus LT more. And then we have C to Z, temporarily stop a process from C to Z. So you press Control Z to temporarily stop it while it's going through more. So you can see what the pages it's going through. Foreground and background. So yesterday I showed you how to run something in the background by using the ampersand. So if you're in the background, FG brings a process to the foreground after it's been stopped. So you can bring the output to the foreground. Or you could bring something in. Vacation turns on an auto reply. Do we have vacation? This is interesting. Vacation. I don't think we're on vacation here. No, vacation is not currently installed. No, we actually have email. I don't think we have email installed either. In fact, we don't have Pine installed either. So let's not worry about email and vacations at this point. But if we had an email client, vacation would turn on our vacation auto reply email. Pine launches the email program. Emacs as well. Starts an editor. Do we have Emacs on here? Good question. We do. No, we don't have it on here. I can install it, but I'm not going to install it because no one's going to use it. Nano's usually pretty good for everybody. So 8 sections in the online manual, if I hadn't mentioned it before. So kind of a review to kind of clean up some of the things I showed you earlier. Commands, system calls are also in the man pages. File formats, games are in the man pages too. Miscellaneous system maintenance drivers, devices, stuff like that. When using the man command, we know how to do that. We type in the word man, we add space, and then the command we're trying to get something for. And Control C will break us out of there. So that was a recap and sort of a conclusion on some of the concepts we looked at without looking at any slides on it. We just basically ran it for ourselves. So what we're going to do now is I'm going to set you, instead of doing it as a group, I want you to do it individually. And what you're going to work on is this next assignment. So the next assignment is the one I showed you in the beginning. And I have it still out here. Here it is, assignment number 4. That's marked 3, but it's really 4. So what I want you to do, and I'll come around and help you, is go through and run this and then give me the answers or write it all up, because you're not going to give it to me. You're going to submit it to the EMS. So you're going to, like for example, if you take it and just pull this down and to fill this out, it says make a new file named test in your home directory. Great. You don't have to do that. Just leave it in your home directory. So leave the output of everything you're doing in your directory. And then change the access so it looks like this. Okay. And then change the permission to this. When you see the line, put the command on the line. That's what the line's for. So write the command that you used. This one we don't necessarily need the command for, number 1, but when there's a line, it means put the command that you used there. And then try to edit the file. What happens when you change it? And you put your answer here. Nothing happens, or then change the permission to this. Well, how do you get it to that? Actually, Dad gave you that one. And you remember what I said about 777. You got that one. So, or you can go, you can do it another way too. So anyway, that's what the line's for. Some people have a problem with the line. And then down here, you won't have a problem with some hard links, actually. The hard links work with the files. And then the directories you'll have to figure out a little bit. So I'm going to give you some time to work on these, actually. So I'm going to stop this video recording.